I know some of this is a little bit of review to you. So a piecewise function is a function that's defined using two or more equations that are true on different intervals, right? So take a look at this first one. Oh, I kept going. Okay, sorry. I double-clicked, I think. All right. So take a look at this one. We want to find the indicated values for the piecewise function. And this is where students all the time, kind of, we kind of get confused. But one thing you want to remember is each of these questions here will only have one possible answer. All right? Otherwise, it won't be a function. Okay? So take a look at how this piecewise function is defined. It's divided into three regions. When x is less than 0, this is the function. When x is greater than 0, this is the function. And only when x is 0 is it that middle function. Okay? So when you want to find f of -3, you want to see what of the intervals the -3 falls into. So you're going to be looking at these numbers here. So where does -3 fall? The first one. I plug it into the function of the first one. I plug it into here. So it'll be -3 plus 2. That's 5. Okay? You cannot have more than one answer for these, because they're only ever going to fit into one. All right? The next one is f of 0. Where does f of 0 fall? The second one right here. The function there is just a 5. Okay, we lucked out. There is nothing to plug in, so you just say 5. The next one, f of 5, falls in the last domain. But what do you do? Where do you plug in the 5? Into the function. So 5 squared minus 1, 24. Okay, questions? Yeah.
So for the first one, we got 5, and then the first thing is like 5 is less than 0. So that's not the case.
The x is like what we're talking about.
So,
oh, it's the -3 is less.
Yeah,
Because
right.
like, look, from 5, like 5.
all right. So here we go. F of -3, right? Where does -3 fall? In the first or in the second interval? Why second? Because it's greater than or equal to. So I plug it into that. It's just a 7, so just say 7. Okay? -6 is in which interval? The first interval. I plug it into the function that goes with the first interval, and I get 3 times -6 minus 1. How much? -19. Okay? All right. Here, I'm not given the functions. I'm given the graph, and I just have to figure out the values based on the graph. So, f of -4 means when x is -4, what's y? When x is -4, what's y? 4. Again, you're only allowed to get one answer, because if you got two answers, it wouldn't be a proper function. So when x is -4, y is 4. Okay? It's on the right. Okay, now, f of 0, when x is 0, what's y? When x is 0, it's 1, right? You have, if there is, two possibilities, you have to go with whatever is a closed circle. So 1. F of 5, when x equals 5, what is y? 1. All right? Those are 3 points. Just be careful. Okay. Piecewise functions. How to graph them. Okay. So, we have done this. You're going to do them like over and over and over again, because it's just a part of math, right? Even in calculus, we see piecewise functions again. Okay? So, again, this step to the right tells you where each of the functions live. That's all. It's the domain, literally where it lives, okay? So this one function lives when x is less than 0. This second function lives when x is greater than or equal to 0. So I focus on that number first, 0. That's where there seems to be a partition, right? So what I like to do, in the beginning especially, I draw an imaginary line. It's not an asymptote, it's just an imaginary line at the partition, okay? Now, that partition divides my graph into two regions, my grid into two regions. Let me use different colors here. This is region number 1, and then this is region number 2, okay? Which function, the x plus 5 or the x squared plus 1, lives in region number 1? The x plus 5. This one lives in region number 1. Region number 1's domain is x is less than 0, this part, and that's the function that lives there. So what lives in region number 2? This one, right? X squared plus 1. So here's what we're going to do. We're going to graph each of these independently of each other. And I want you to plug in points, okay? The first point you're always going to plug in is the partition point. If x is 0 is where the partition is, that's where you plug it in. If it was x equals 3, that's what you would plug in. So x is 0 into the first function, y is 5. Okay. So I go over x is 0, y is 5, right? That's going to be right over here. However, because this one is an open circle, just less than, not less than or equal to, I have to put an open circle there, right here. Okay. Next. So take a look at the x plus 5. That's a linear function, right? So I can visualize that I'm just going to get a line there, a slanted line, a linear graph. What I'm going to do is I'm going to plug in another number from this region to the left. You can plug in whatever you want. Once you plug in the partition number, -1, -2, -5, whatever you want, all right? Let's do -2. I plug it in, what do I get? 3. So at -2, it's 3. At this point, there is no like open circle or closed circle business. It's just a point through which your graph is going to pass. All right, so I know that that was going to be a linear graph. So I just draw that right there. Okay? Yeah. It's an open circle. So here, you see how it's less than, not less than or equal to? That tells me this one, the circles only matter on this partition. Everywhere else, it's just a dot through which your graph is going to pass. Okay? Yeah.
How do you know the partition?
Was that 0?
Yeah.
Because of this. One is, so this one is x is less than 0. This one is x is greater than 0. It's being separated as 0.
So will those always be the same?
Yeah, they should be. I mean, there'll always be like one point where they separate from. Okay, let's do a couple more, and then you'll see what the next one. No, not the average. It's literally okay. Let me graph it, and I'll tell you. Okay, the other one, it's x squared plus 1, right? I'm gonna graph it in the blue region. Again, the first point I put in there is the 0, where the partition is. So I get 0 plus 1, 1. So when x is 0, y is 1, here, because it's greater than or equal to, that's going to be a closed circle right there. Okay? And what's that graph? It's an x squared plus 1. That's a parabola, right? So I know it's going to look like a parabola. I have that in the back of my mind. Now I need to plug in another point from that region. So give me a point to plug in. 2. Let's do 2. When x is 2, y is 5. When x is 2, y is 5. All right, that's going to be a parabola. Sorry. So it's going to look like this. Okay? Yes? Yeah, it would be okay.
So is that 2, 5 a point, or is that just a...
2, 5 is a point on the graph, right?
So you want us to go back to
Okay, it's just a point. Okay, this is just like the 5 points you were putting yesterday on your graph. The only place where open and closed circles matter is on that partition. Anywhere else, it's just a point through which your graph will pass, okay? Now, one other thing before I take your questions. On this partition, you are never allowed to have 2 closed circles, right? Never 2 closed circles, because then it won't pass the vertical line test. You can have 2 open, 1 open, 1 closed. But if you have 2 closed circles, don't write this down. If you have 2 closed circles like this, that won't be a function. It won't pass the vertical line test, right? Don't write that down. Don't come to me later saying you put 2 closed circles there, because I will never, okay? Yeah.
Is it possible to do on the points from like the same side?
No. Okay. All right, let's do another one, and then hopefully some of these like what if questions will, like you'll see a trend. Okay, take a look at this one. Now we have 3 different functions, okay? So look at the first one. It only lives when x is less than 0, okay? The other one goes from 0 to 3. So this first one lives when x is less than 0. So there is a partition right there at x is 0. The other one goes from 0 to 3, and then the third one takes over from 3 and on, okay? So there is another partition at 3. So basically the way you want to do it is, right? Each of the values that are represented in your domain are going to get a partition, okay? Okay, so usually when you have the 2, that's when it makes a little bit more sense. Okay, now I have 3 regions, 1, 2, and 3. All right, and I like to go and I like to label the functions that are going to live there. This is function 1, this is function 2, and this is function 3. Those are the ones that live in those respective houses over there. So, graphing region 1, it's negative x plus 3. What kind of graph am I going to get? Linear, parabola, what? Linear. Okay, so what's the first number I'm going to plug in there? A 0, because that's the partition, right? That's where the dotted line is for that region. Okay, so 0. And y will be 3. What's another point I'm going to plug in? Yeah.
How do you want 0, 0
No, because now when x is 0, y is 3, when I go there, because of what you're saying, I have to put an open circle there. Okay, so you can plug it in, it's just an open circle. Okay, you just can't put a closed circle because it goes right up to that point and then it stops. Okay, another one, I heard negative 2. What do we get for y? Huh? Anything from this region will work. Anything in that region, yeah, anything to the left of 0. So that's going to be negative 2 plus 3, 5. So when x is negative 2, y is 5. Yeah, so, go ahead and plug those in. Okay, now, next one. Yeah, so you know how to draw the graph, right? Oh, I see, the corner points. As long as you did the table, it's okay. All right? Okay, so next. Oh, yes, I went off one, sorry. Negative 2 and 5. Here? All right. Now, the second region has 2 partitions, one on the left, one on the right. Yes? So I'm going to plug in those 2 points, right? Because I have to plug in this partition point, and I have to plug in that partition point, and it should really be enough, right? So I'm going to plug in 0, that's the first partition, and I get 0. So that's 0, 0. Open or closed there? Closed. The other one I'm going to plug in is x equals what? 3. And I get 6. 3 and 6 will be open. Okay, and that's a linear function, right? So I have to draw a linear graph. If it was a parabola, I would just curve it and make it look like a parabola.
Wait, why is that different?
Okay, so here at 3, it's a less than, not a less than or equal to. Okay? But here at 0, it was greater than or equal to.
Since there's a point on each partition, do you not extend the line past the point?
You cannot extend it past the point. The domain. Yeah, okay, so this whole part is the domain of this one, right? So it lives in this entire region. This one, the blue one, only lives in this little strip. Now number 3 will be able to live in that entire region over there. Okay? Okay. So next one. What's the first number I'm gonna plug in? A 3. And I get root 4, which is 2. Open or closed? Closed. 3, 2, okay. And then now you have to decide what other number to plug in, right? You are free to plug in really whatever you want. But I like to sort of like think ahead, and I like to plug in a number for x that's going to give me a perfect square in here. So for example, if I plug in 8 is a good one to plug in, right? It'll go off of the graph, right? So if I hate extending them, I should have extended it before. Okay, don't ever do what I'm doing because it does not look professional. Okay, so sorry, my allergies are so bad and my eyes are just watering. So when x is 8, what's y gonna be? 3. Okay. Right, so if you were drawing your grid, let's say, you would extend the line, or if there was a grid already given for you, we kind of think ahead to like calibrate it so that they would all fit. Okay, now look, I kind of did that there before without talking about it. This is a square root, right? You know what a square root graph looks like because you're now a sophisticated precalculus student. It looks like that curve, right? So from here to here, you have to give it that curve. And when we're grading these, right, what we want you to be super meticulous with are the points on the partition, right? Like this one is a linear graph, this one is a linear graph. It's not that difficult to get that pretty precise, right? When it comes here, like we are not going to, bust out a tool and be like, okay, let's see if they have the correct curvature. However, if you have a straight line going from here to here, it looks like a linear curve, it's not the correct graph, so it's wrong. All right? So give it that curve. Okay. Now, look at this. On each of the partitions, we never ended up with more than one closed circle. Right? That's important. All right? Okay. Questions? No? Okay. So, okay, so for this one, go ahead and put in the partitions for me. Yeah. Because I do want you guys to be filling them out and stuff. Yeah. You can always come back and, at the end of the class,
X equals plus 2.
it's an important skill, right? So you learn how to teach math notes live. right? Those are the kind of skills we need you to go to college with. Yeah.
Like if I graph that like a
Yeah.
so
So let's do that.
linear graph, so when I just in a half graph.
Part of it might.
I don't know.
Hang on, let's do this. So I have a partition at 0. So did I do this correctly? Are my partitions where they should be? Okay. Now, when it comes to these, now things are getting a little tricky. Okay? Before you graph anything, you should always have a visual in your mind of what it looks like. So, take a look here for a minute. Let me have everybody's attention up here for a minute. You have region 1. This is what we're gonna graph in region 1, right? This is an absolute value of x plus 2. The plus 2 will have shifted the absolute value to the left, right? So if there were no partitions, if there was not a piecewise function, if this was the only thing we were graphing, I need to be able to visualize how it looks. It would have looked like this, right? Don't draw it just yet. It would have looked like that, right? Well, like this. Yes? Okay, so once you visualize that, you'll know how to do your points and, how you should make it look. Okay? So the first one I'm going to plug in here is x is 0, and I'm going to get y equals 2, and I'm going to put an open circle there, correct? And I already knew that the vertex was going to be over here. So maybe now I'll plug in, I don't know, a -4. And I'll get another 2. So now I can draw that like this. But now, there is no way I would have been able to do this if I didn't know from the beginning what this would have looked like. Okay, so I'll go through it again. Let me take your question and then I'll go through it again. Okay, so let's do it again. Yeah. Okay, so yes. Okay, so let's do it again.
How do you know that that's
Okay, so let's start again. Okay, so let's do it again. Okay, this is an absolute value function, and it's x plus 2. We learned yesterday that the plus 2 shifts the graph to the left 2 units. So if I were to graph this without any partitions, this would have looked like an absolute value shifted to the left. That's what it would have looked like if this was not a piecewise function. Okay? Absolute value graph shifted to the left. Bearing that in mind, I now go and do the whole piecewise function business. I plug in a 0. That gave me a 2, and that's an open circle there. Now, I knew, because I know that this is an absolute value function shifted left 2 units, that the vertex is there. And so I can now plug in any other point I want just to see how it's going to look. You can do -3, -4, whatever. If you plug in -4, you get a value of 2. And when you graph, that's what it will look like. Okay. Huh? Okay, because if you go back here, this is an absolute value function. Yes, that's the vertex. It's an absolute value function shifted to the left 2. Okay, so now, you should always do this for all of the ones that you're graphing, right? Have an idea in your mind of what they look like. So the next one here in region 2 is again an absolute value function. This time it's shifted where? Down 2. Because the -2 is outside, it affects the y. So this is a vertical shift down. Okay? Where is the vertex for it? So at 0. Okay, so at x is 0, what would y be? -2. Open or closed? Closed. Okay? Now, because there is another partition, let's plug that one in as well. 2, and I get 0. Open circle there. That's how that looks. No, there is no other side, right? Because it's only bounded in between these two partitions. Okay? It's not a curved line. It's a straight line. It's an absolute value. Okay. The next one is a square root graph, right? So it's going to look like a square root curve. Okay. What do I first plug in? A 2. And I get root 4 plus 2, 4. Root 4 is 2 plus 2 is 4. And at 2, it's 4. Open or closed? Open. We got 2 open circles there. That's fine. We just can't have 2 closed ones. Okay? So what other number can I plug in here? A 6 will give me an 8. So maybe a 7. A 7 will give me a root 9. Right? So what I always try to get a perfect square inside the root. So if I put in a 6 here, I'll get root 8, which I don't really want. But if I put a 7, then I'll get a root 9, which is 3 plus 2 is 5. Yeah. So 5. So here at 7. All right, and we are going to curve that a little bit because it's part of that square root curve. Okay? Okay, so now.
Wait, wouldn't it be 7 in the y value side?
Yeah, here. 7 and 5.
Oh, that is 5. Oh,
okay. Okay, so, it does take a little bit of, it just takes a little bit of patience, right? And a little bit of like, you have to be detail oriented. You have to be meticulous with it, okay? So, are there any other questions? Huh? Okay, well, you know, what's simple to you might not be simple to anybody else, and vice versa. We need to practice. Okay.